Last section of the chapter. Let's get into it. Now, this is the type, okay, I giggle, because this is the type of problems we're doing. But like I said, this one, I'm not going to use binomial expansion. I would just FOIL it out, which most of you could do in your head. So we can FOIL that. We're not going to get crazy. We're going to have minus 6x in the middle. Done. Okay? Let's not spend any more time on that. Cubed. Let's FOIL it. Let's go old school, because clearly I haven't taught you binomial expansion yet. I kind of cringe a little bit on this, just because I feel like it is going to be a lot of distributing. I'm going to start with these first two expressions. I'm going to FOIL those together. I'm going to go ahead and combine the middle, plus 2 for a total of 4. And then 2 and 2. And now I'm like, oh, good grief, we're still going. I'm going to have to distribute this together. X and x squared. Remember, ordering multiplying doesn't matter. I'm going from the back to the front for whatever reason I feel like it, I guess. X and 4x. X and 4. Still going. 2 and x squared. 2 and 4x. That was really fun. 2 and 4. And of course, we're going to combine the like terms and now put it in the correct order. Still going. 4x squared, 2x squared. I'm going to combine it to 6. 4 and 8x, 12, and 8. Now, bless you. I don't know about you guys. I found that a little obnoxious. Let me ask you this. What if I was super mean to you and I gave you x plus 2 to the 8th power? I would probably cry. That would probably take half a sheet of paper. Right?
I won't even do it.
Guess what? I could have done this problem in 2 lines of work.
Calculator.
I can do it to the 8th power in 2 lines of work. So that's what we're going to show you today, this binomial expansion. 2 lines of work, I can do all of these. I mean, the first one I would just FOIL.
Couldn't you just add 4 of those Johns right there?
So first, it's all about patterns. We got to talk about the patterns here, okay? So if you take a look, and I just used generic A and B for the variables. Now, I went through, I multiplied them out, I combined the like terms, I did all the simplifying. So look at some of the patterns. The coefficient on all the A's, of course, are 1. We know that. Like Pascal's triangle, they all start with 1. And notice all the coefficients on the B's at the end are 1. Like Pascal's triangle, they all end in 1. So Pascal's triangle is going to help us get these coefficients on the terms. If you look in Pascal's triangle, on the very back page, which we're going to make from scratch here in a minute, you will see there's a row with a 1, 3, 3, 1. A 1, 4, 6, 4, 1. So on and so forth. We're going to use those values to help us get the final answer in our 2 lines of work today. So, few little observations we need to make here, because like I said, it's all about patterns. What's the relationship between the number of terms in the answer on the right side and the exponent of the expansion? So like here I've got squared 1, 2, 3 terms. Cubed 1, 2, 3, 4 terms. To the 4th power, 1, 2, 3, 4, 5 terms. All right, what's your observation?
You add 1.
You add 1. You have 1 additional term. So I'm just going to put 1 more term than the exponent. That is my conjecture today. That is true. We're not going to prove it with mathematical induction. Okay, now other observations. Exponents. Let me erase all my crazy writing up here. So I'm looking at the powers. So let's start with, it talks about A. So A's to the, I'm at the bottom row. 5th, 4th, 3rd, squared, 1, 0. Pattern's the same on all of them. Here A starts at 4, 3, 2, 1, 0. 3, 2, 1, 0. So the exponents of A are decreasing. They're going down by 1. Now let's look at B. Start at the beginning. So really you have B to the 0, 1, 2, 3, 4, 5. B to the 0, 1, 2, 3, 4. So the exponents of B are increasing. They move up. And that is always the pattern every time we do it. And it's kind of weird with the A and the B, of course. We're going to get real numbers in here. So the first term, the A, the first term of your expansion starts at the power, so 5, and goes down. The second term in the binomial, B, starts at 0 and works its way up. And that is always the pattern. Okay, sum of the exponents into each term. Well, we've got 5, 4 and 1, 5, 5, 5, 5, 5. The exponents should always total to your expansion exponent. So I'm just going to say equal, I should have put a longer blank here, equal the exponent.
Oh, that does not.
What did you put?
5.
Interesting. Okay, on the last one it would be 5, yes. Now, 2 ways to go about getting these coefficients. When I talk about the coefficients like this bottom row, I'm talking about the 1, 5, 10, 10, 5, 1. Or the row above it, the 1, 4, 6, 4, 1. You can get those, you can see those rows on Pascal's triangle. I like Pascal's triangle because I make it once and I use it for everything. You can also do it with combinations in your calculator. Do I care how you do it? No. I'm going to show you both ways, okay? So if you're going to get the coefficients, it's in your calculator. That combination, I'm going to show you here in a minute. It's in your math menu. It's under probability, and it's number 4. Just for the record. If you're just getting your calculator, good deal. So, same deal. First term of the binomial starts at the exponent and goes down by 1. The second term starts at 0 and goes up. So let me just, on the calculator before we get into this, so remember, like I said, what do we got here? It's under your math menu, probability, and I just left arrow over, you can do whatever, and you're going to be using number 3. Now, I'm not going to type anything in yet because I don't have any numbers, but we'll get to it. And again, I don't care how you do these, I'm going to show you both ways. Okay, so I personally do not like to do the combinations because in my eyes, it's kind of time consuming and a lot of calculator keystrokes for something I could get all off Pascal's triangle. So one of the things come quiz, test, etc. time is you're going to have to be able to make the triangle from scratch.
No.
It is not going to be that hard. And I'm going to show you how to make it. I'm going to show you how to make it from scratch here in just a minute, okay? So just bear with it. Bear with it. Okay.
Yeah, you definitely.
What happened to my example 1? Are my slides out of order? My favorite way to do this, but I'm going to show you how to do it with the combination. And you can kind of see the pattern up there. So first zero in on your expansion power, which clearly is a 4. So that n over 0 is the same thing. It's just a shortcut notation for that. I don't care how you write them. I'm going to put the actual C's in there just to focus on that on our calculator. So first thing I would calculate is combination, our exponents 4. And then I'm going to get to the next term. It's going to be 4, 1, 4, 2, 4, 3, 4, 4. We'll get there. Now, other things. First term of your exponent, x. That starts at the power. Your second term of your expansion is y. That's going to start at 0. So I always think high-low. You start at the power, then you start at 0. Now, let's be real. Do I ever really write y to the 0? No, that's not worth it. Anything to 0 power is 1. Now, to get my next term, my combination for my coefficient will be 4, 1. So I have to punch that in the calculator. X moves down in power, and y goes up in power. My next coefficient is going to be the combination 4, 2. X is going to be down to the squared. Y will be up to the squared. And remember, your exponents on your term should always total to 4. A little safety check. All right, we're at combination 4, 3. X is going to be at the first, y at the third. And my very last term of my answer, combination 4, 4. X would be at the 0. Personally, I wouldn't even bother writing that, especially I'm kind of running out of room, but I'm going to throw it out here for the pattern. And y to the 4th. So this is what I was saying. I can do this in 2 lines of work, my friends. 2 lines of work. All right, calculator time. I'm not going to punch every single one in because it's obnoxious and nobody wants to watch that. So first, when you type these in before you get into your math menu and probability, you have to put that first subscript 4 in. Let me minimize this. Pull up the old calculator. So I'm going to put 4, math menu, probability, number 3, and then 0. So that gave me 1. Well, that was really exciting. So my first term, 1 x to the 4th, 1. Now I'm going to type in the next one. This is very exciting. 4, math menu, probability. 1. Okay, and I got 4. Well, that's exciting. So my next term is going to be 4x cubed y. I think you can all handle typing in the combinations. I don't need to keep going, right? I can just tell them to you. The next one's going to be 6, x squared y squared. Then I typed in combination 4, 3. It's 4. And then the last combination 4, 4 was a 1. I'm not writing a 1. X to the 0, I'm not writing that either. Now, personally, I don't like typing in all of those combinations. I find it tedious and I find it time consuming. Plus, if you look on your big Pascal's triangle on the back, there's a row with 1, 4, 6, 4, 1 in it. So once you make the triangle, that's where we're going to get those coefficients. So I'm going to show you how to make the triangle. So, easy way to make the triangle, super easy. So it always starts with think about when you space it. I'm going to try to put it in the middle, and then I'm going to have the 1s on the outside. So I kind of start in the middle of my space with a little triangle of 1s. Little triangle of 1s, nice and easy. So move it over to the left, start with 1. Now, most of you already looked at it and figured out the pattern. How do you get the middle number?
You add the 2 on.
Yeah, 1 plus 1, end with a 1. Start with a 1, 1 plus 2, 2 plus 1, end with a 1. Now, how many rows do we have to make? Well, I probably should make a few more. 1 plus 3, 3 plus 3, 3 plus 1. There were my coefficients I just ended up with on that last problem. I had 1, 4, 6, 4, 1 on mine. Now, so that means, of course, for our expansion exponents, the very top one is for your power of 0. This is for the first power, second, third. We just did the 4th power. So here's what I'm going to do. I don't get too crazy here, like as far as how many rows I'm going to make. I'm going to kind of look ahead and see what's my biggest exponent. 5th power, okay. 4th, all right, I got 4th. Oh Lord, 6. Okay, so I got to add 2 more rows so I have it out to the 6th. That's fine. I got it. 1 plus 4, 6 plus 4, 4 plus 1. So there's my 5th, and we've got that last one out to the 6th. 1 plus 5, 10 plus 10, 10 plus 5, 5 plus 1. Okay. Now, obviously, for today, you know, you've got the triangle in your notes, but you are going to have to make it from scratch. Yeah.
How does one come up with this? Like, how does
Pattern, somebody realizes it. Now, here's the thing. Like I said, I don't care on your test Friday if you do the coefficients from the triangle and there's space on your test to make the triangle, or I just find it irritating. If I didn't want to make the triangle, I have to type in my calculator 6C0, 6C1, 6C2, 6C3, 6C4. I'm already tired of even just reading them off. You would have to punch all of that in your calculator, and I find it tedious, okay? I'd rather make the triangle. So here we go. 2 lines of work we're going to do this in. Now, to the 5th power. So first thing I'm going to do, this isn't really one of my lines of work, people, because it's in front of you. I'm just going to jot down those coefficients so they're in front of us. 1, 5, 10, 10, 5, 1. 5, 1. This is not one of my lines of work. I'm just stealing that so it's in front of us, okay? So, first off, 5th power, we should have 6 terms in your final answer. You always have 1 more term than the power. First coefficient is 1. Now, it's going to take me a little longer because I'm going to kind of color code it. You'll probably set it up quicker than me once you figure it out. First term of the binomial is 2x. That starts at the 5th. Your second term of the binomial starts at 0. Now again, if I'm actually doing this, would I write 3 to the 0? No, because it's 1, it's not worth my time. So that's going to give me the first term. Next coefficient, 5. 2x moves down in power to the 4th. 3 goes up in power to the 1st. There's my second term. Third term, 10 for a coefficient. 2x is going to be down to the third. 3 will be at the second. And I mean, yes, you could just put 9, I'm aware. Okay, I'm just setting it up for the pattern. Okay, next term, our coefficient, another 10. 2x is going to be down to the second. And 3 will be at the third. I know I'm going to run out of room. All right, next term, 5. 2x is down to the first. And 3 is going to be at the fourth. I'm running out of room. I'm going to sneak the last term under here. 1. Now, normally I wouldn't even bother writing this because 2x is at the 0. That's really not worth my time, but I'm going to throw it on here for the pattern's sake. And 3 will be to the fifth. So in theory, like I said, 2 lines of work. I just ran out of room. Okay, ran out of room. All right, here's where you have to have some good calculator skills and you have to watch your exponents. This exponent of 5 does apply to the 2. So maybe you know this. What's 2 to the fifth? 32. So my first term, 32x to the fifth, because I don't care about anything to the 0 power. Now, same thing here. You're going to have to be conscientious of your exponents. So in my calculator, I'm going to do 5 times 2 to the fourth times 3. We know 3 to the first is 3. So what's your second coefficient? What's 5 times 2 to the fourth times 3? 240. Thanks, Elliot. Perfect. And you get some big numbers. You can see I clearly don't have these memorized. I got to look at my cheat sheet here. Next, you're going to do 10 times 2 cubed times 3 squared, or 10 times 8 times 9. What's your next coefficient? 720. All right, what's 10 times 2 squared times 3 cubed? 1080. 5 times 2 times 3 to the fourth? 810. 1 times, who cares? We've got 3 to the fifth, really. 3 to the fifth, 243. Got it. That is way quicker than if I were to write 2x plus 3 down 5 times and like had to FOIL it all together. Take me a half a sheet of paper. Okay, so just be conscientious on your calculator, applying those exponents to the numbers when you type that in. All right, let's do another. Fourth power. Okay, all right. So first I'm going to look at my triangle, fourth power. I need the 1, 4, 6, 4, 1. I'm going to jot that down quick. This is not really part of my work. You've got it in front of you. So remember, 2 lines of work. First coefficient 1. First term of our binomial 3x. That's going to start at 4. Now, negative 2, I should say, negative 2 will be at 0. I don't know if I'd really personally bother writing that, but I'm going to put it on here. Okay, that'll give us our first term. 4 is our next coefficient. 3x is going to be down to the third. And negative 2 at the first. Third term. 3x goes down to the squared, and negative 2 is at squared. All right, 4. 3x is down to the first, negative 2 to the third. I think I'm going to fit it in one line, maybe. 3x is at the 0. Like I said, I normally wouldn't even bother writing that, but I'm just going to put it for our pattern. You don't have to include that. And negative 2 at the fourth. Sneaking in the fourth. Okay, we're going to be super conscientious with our calculations here and our signs today. Okay, who cares about 1? I'm not going to worry about that. Negative 2 to the 0 is 1. But, well, you should know it maybe. What's 3 to the fourth? 81. 81.
81 is
Okay, careful on this guy. We're going to do 4 times 3 cubed, or 4 times 27 times negative 2. What's 4 times 27 times negative 2? 4 times 27 times negative 2. Perfect. Don't forget your x cubed. 6 times 3 squared. I mean, I'd put 9 in my calculator. Let's get serious. 6 times 9 times 4. 216.
I use my calculator.
4 times 3 times negative 8, really. 4 times 3 times negative 8. What's that one? Got it. 1 times 1, whatever, who cares? What's negative 2 to the 4th? Got it. So notice on this one, patterns, all about patterns. What do you notice about the signs on the terms? Flippity floppity. They're alternating from positive to negative. I knew that was going to happen from the original problem. Why? Because of the subtraction. That will happen every single time when you have subtraction. The signs do alternate from positive to negative. Okay. Last page. You tell me, do we need to do C or are you okay with the pattern?
We got her down.
Alex says yes. Okay, all right. So, moving on. How to find a term. Now, notice, okay? Notice. We've got a 9th power. I only went out to the 6th on my triangle, so I'm going to have to add some rows, or you're going to look at the one on the back. Okay. Now, 6th power, find the 4th term. So you need to look at your triangle, of course. I'm going to click it back to the triangle. I'm looking for that 6th power row, 4th term. So here we go. Let me go back here. 6th power, my last row. So I kind of like these better because I only need one specific term. I don't have to do the full expansion. It wants the 4th term. So start at the beginning. I'm going to count 4 in. 1, 2, 3, 4. So my coefficient would be 20. So let me click ahead and jot down to 20. Now, remember, x would start at the 6th. So again, I'm just counting it. This would be x to the 6th, x to the 5th, x to the 4th, x to the 3rd.
Wow, Alex, you can count.
Okay, second term's negative 3. Now, here's my pro tip or my hack for you. I don't count in the second term because remember, these exponents should always total your expansion exponent. So what's the exponent on negative 3? 3. Because I need them to total to 6. I don't have to count in the second term. Okay, we do need to simplify this though. What's 20 times negative 27 really? Got it. Okay. Now, you are, for the 9th, you are going to have to
Use the thing on the back.
the big one. The big one. Okay. Remember, I ended up 0, 1, 2. Which term do we need?
The 8th.
8. Okay. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8. Here's my 9th power row. And I need the 8th term. I'm going to count 8 in. 1, 2, 3, 4, 5, 6, 7, 8. So my coefficient we're going to use is this 36. Let me back it up here.
6.
Now my first term's 4x. I am going to count that one in and we'll figure out 3y in a minute. Okay, let me get to it. 4x to the 8th. Are we on the 9th? 8, 7, 6, 5, 4, 3, 2, 2, 2, squared 2. Okay, mental math, what's going to be the power then on 3y? 7. Ooh, we're going to get a big number here. Yeah. What is 36 times 4 squared times 3 to the 7?
1,259,712.
Just say the individual number.
I just like hearing you say, can we read the number?
I just did.
Read it again, give it to me.
1,259,712.
X to the
Second.
I did that in my head.
y to the,
7.
okay. All right, last one. So 8, and I need the 6th term. So 1 row up, 6th term. So 6 right here, 56. Okay, I'm going to count it in. We need the 6th term, so A is going to start at 8. One more click here. So So a to the 8, 7, 6, 5, 4, 3. And what's going to be your power on 2b?
5 plus 2.
It's going to be
Five.
5. 5 plus 3, 8. Okay, so in your calculator, what's 56 times 2 to the 5th?
1?
Just say-
1792.
Really?
All right, any questions on that?
This is a good
I know, I like binomial expansion. It's got a little time consuming to calculate all this
That's the
stuff.
worst thing about
It's
it.
easy. Do you like this better or worse than mathematical induction?
I like the inductions way more.
Really?